Okay, so hi everyone. So this session is about self-contained repos. Um, so what we are been talking today is about the overview of the whole project, our current scenarios and challenges, the refactoring goals, implemented solutions so far, key results, list of contributions that we have already made, and the next steps. So first, what is this project about? So basically to make easier and standardize the way that we do development on all the repositories and modules that belongs to the OSM project. So the first stuff is about streamlining testing using standardized Docker image for talks. So basically make easier to execute talks test, on every single module. And you will be see later that basically what we did is one single command will work for basically all the modules that we have on OSM. And then the other, let's say, goal or item in this project will be Dockerfile refactoring and migration to individual module repositories. So we can have every repo will have its own Dockerfile. Also aim to reduce dependency of centralized DevOps repository. So as I already mentioned, what we want is to get rid of all the dependencies. So every single repository can work by itself and will be easier for development. And then enhance modularity, efficiency, and maintainability. The project has been split in 3 phases. First, phase 1 is about stage 2 or executing talks test, and we are standardized Docker image. This phase 1 has been already complete. Then we have phase 2, which is individual Dockerfile per repository, and this one has been already complete. And then the phase 3 is the one that we will be start working in the next future, or the short term, which is individual Jenkinsfile per repository. And with all 3 phases, so what we want to achieve is basically having every single repo with their own dependencies by itself, so it doesn't require from complex workflows to be executed. So let's talk now about the current scenarios and challenges. So about current scenarios and challenges, the first one is fragmented workflows. As I already mentioned, deployment Docker files were stored in separate DevOps repository, making rapid development and testing difficult and slow. So basically, every time that you need to, let's say, build the Docker image for testing any of the modules of OSM like NBI or LCM, you cannot do that, let's say, easier, because you need like other dependencies, like for example, the Docker file that are not within the repository. You need to get the DevOps repository as well, identify what is the actual Docker file, and then pass, like, let's say, it's a bit more complex Docker build syntax for getting that installed in your own machine for rapid development. The second item, which is complex dependencies, which is the one I found the most, let's say, cumbersome one, and especially because I am a new member and getting started in context about OSM development. And the thing is that basically all the image today relies on Debian packages. So basically every module is packaged in a Dev file and then installed as a Debian package within the Docker container. But there are few stuff that are difficult to look at. For example, where these Dev files are being packaged, right? What is the actual content that is within the Dev file? So basically we rely that everything is what we want, and right now is actually working. But from the point of view of rapid development, on looking at how this is being done, is quite difficult and quite complex. And also seems like everything is, let's say, intended to work properly within the Jenkins pipeline and the whole environment being set. But when we talk about local development, you have to get a lot of tools and a lot of things already configured in order to get it work. And that's very, very complex, and especially when what you need is to development, right? You need to do the development, you want to do that easier and faster. Then we have bloated images. So basically, all our Docker images are based on Ubuntu, especially because we rely on that packages, so we need a Debian-based operating system, and that results in large container images that, beside of the size of the image, it also can introduce more attack vectors because we are having a lot of basically packages that probably we don't need. And then unnecessary builds. So, and this is especially for the tox test. Nowadays, executing tox basically implies to build a Docker image with a container that will have the tox tools inside, and then execute the tox script within that Docker image. And this happens in every pipeline execution. And this is also true if you do that locally. And what we did, and I will show you this with more detail later, is to make this process as well easier. So the refactoring goals, again, streamline testing using a standardized Docker image for tox, decouple module dependencies to ensure module independence, consolidate Dockerfile within each module repositories. This is a key part. Then refactor OSM Docker files. So no more devs. We are not going to use more dev packages for installing our Python applications. Now the Docker images are based on Alpine Linux, which is way much smaller instance or image, and let's say slim. And then also IAM and common packages are installed via pip. But when I say pip, it's basically we are cloning the repositories and then executing the pip install within the Docker file, which is way easier to understand when we are building the image and reading the Docker file. And then standardize the official Python images based on Alpine Linux to reduce image sizes. So basically, as I said before, we were using Ubuntu-based images. Now we are using Alpine, but not only Alpine. We're using the official Python images for Alpine Linux. In this case, Python 3.10. So let's start by the simplified tox execution. So basically, we modified tox execution mode to prevent the persistence of residual files. And to achieve this, the module's execution directory is mounted on read-only mode. What all this stuff means. So basically now when we execute tox, in the past, basically we were mounting the source code within the tox Docker image. And in there we have full read-write permissions. And basically every time that we execute tox, we could lead to have residual files within there because we were adding files within that image. Every tox execution is created in that tox folder, for example, and we basically were writing in there. But the first part of what looks like a terminal section is a Docker file. And this basically what we are doing is that we started to use tox. The base image that we are using is the one that the tox project recommends for using. And basically, the only thing that we are doing is basically installing few packages that we need to get installed in our Docker image in order to get tox properly working across all our modules. But then this image is going to be created and pushed to a Docker repository, a Docker registry, sorry. You don't need to build this image anymore. So basically what you are going to do is to use that image that will be common for all the modules. And the way that you are going to execute tox in this part will be basically only executing Docker run. So you don't have to do the Docker build. And not even Jenkins will have to do the Docker build. It's only executing the Docker command. We are going to create a Docker container based on the shared Docker image, which right now doesn't have a proper name. And then what we are going to do is to mount our I'm sorry for that, our source code within the Docker image. And this will be automatically And actually, I didn't add the proper command, but basically what we're going to do is this volume will be mounted within the containers as a read-only file system. And then from there, basically you don't even need to pass a command, but you can. So basically by default, it will be looking at the stage test.sh script and will execute it right away. So, and that's all that has to be done for executing tox test. Any questions so far here? Okay, perfect. Let me continue. Secondly, so we continue with implemented solutions. So optimize base image, transitioning from Ubuntu to Python 3.10 Alpine. And from here, I decided to not show the whole Dockerfile because it could be a bit cumbersome. So I'm just showing the key parts of the Dockerfile. So basically, we are executing multi-steps, multi-stages Docker builds. And the first one is basically every single module that relies on Python, obviously, will start from the Python 3.10 Alpine image. And these are going to be our base image for all the other stages, build stages. But also, we also transitioned non-Python applications. So for example, for Node.js applications, we are starting from Node.js Slim. And this one is because Node.js is a bit, let's say, special. So we use let's say the Debian one for compiling and packaging the Node application. But the final stage is basically based on Alpine. So we are going to copy only the package JSON, Node.js files within the Nginx Alpine image, and that the final result is that we have much more smaller instance of Docker images for running our Node.js applications. So security best practices. We reduce the attack surface, sorry for this type of, by minimizing the final image to essential components. So basically on the last stage, which is that is building the actual final Docker image. The first thing that we can see that we are running as a non-privileged user, but also we are only copying the necessary files within that final image. And as you can see here, for example, for Python applications, basically what we do is as we are now, let's say Python centric, we are not using that files anymore. So all the stuff is being built within the virtual environment, and the final virtual environment that is the result for the build stage is the only thing that is going to be copied to the final Docker image. That makes our instance only, or our final Docker image will have only what it needs to run or to execute. Finally, standardization. So introduce common Dockerfile templates, Python tooling. So we are going to start using Pit and virtualenv. As I said, no more dead files. Every single application, what we have is it will initialize the virtualenv, and then copy from the build stage the virtualenv to the production image or the final image, and then execute the module as a Python module as it is. So key results. What we could see with this all this job. So the first thing, repository autonomy. Docker files are now self-contained within each module repository. Simplified test execution. Test is executed via shared standardized Docker image, as you saw, without additional builds. So basically, one single command should work for most of for all the Python modules. And with the repository autonomy, as you saw, we don't have this depth dependency anymore. So we basically are cloning with Git, installing with pip all the libraries that we need for running the different modules that we have in OSM, and everything will live or reside within the module repository. So we don't need more the DevOps repository, at least not for the Docker building process. And image size reduction has been achieved about 10 to 20% size reduction. In certain cases, even more. But here are some examples. For example, open source Mano NBI testing daily, which is the Ubuntu base, is 226 megabytes against the NBI Alpine V1 Beta 1, which is 166 megabytes. So you can see here, like, it's a huge amount. LCM is even higher in here. Yeah, so also for NGUI, I wanted to show, for example, this one is based on Node.js, and this one has a huge improvement on sizing because basically that's because of what I show at the beginning in here. Sorry for this. That we are using we are using Debian for the first stages, but we are just using it because it will be easier for compile the whole thing. But then the final image is an Alpine one, which is coming from Nginx Alpine, which is way slimmer, and we are just copying the actual final Node.js file that we need for executing NGUI. So the result is that we have like only 57 megabytes final image. And here you can see the list of contributions. So basically here are all the Docker files, all of them based on Alpine for the different repositories, MBI, LCM, Mon, NGUI are all, even the test image now is based on Alpine, OSM client, NGSA, and DevOps. So next steps, what will be the next step? As I've been mentioning several times now, Jenkinsfile refactoring and consolidation. And when I say refactoring is because, for example, for the docs execution, we have a stage in which the Jenkins file is basically building the docs image. That is not required anymore. So we need to ditch off that part and just executing the new docs share image. Also, we need to refactor a bit to get the new to build the Docker containers now without using the DevOps repository, but instead using our own the own module repo. Yeah, refactor stage 3 to install the latest generated image per module. And also important, very important, one Dockerfile and Jenkinsfile per repository, which is not true right now. Like, for example, the NGSA repository have 2 Docker files because basically there are two, let's say, two components within the same repository, which is Airflow and the Webhook translator. But also moving out from the DevOps repository, components like OSM care and functions, Keystone, and other components, taking that out from the DevOps repository and having them in their own repo with their own Docker file. And with that, so that's all on my side. Thank you so much for attending, and questions, doubts? Perfect. Thank you so much.